Hello, everyone, and welcome to another session on how to use Qdrant. Today, we're going to be covering how to create a semantic search application to search over music data. So, the name of the repo is music-semantic-search, and you can find it freely available in GitHub. This is the app that we're going to be creating today. So, it's music search with Qdrant, a new way to find music. So you're going to have a list of songs to find, and then you're going to get the most similar ones with images describing what's happening. So a couple of things that you're going to need from this repo. You're going to need the payload.csv, and you're also going to need a file with the embeddings. If you're interested in learning how to create these embeddings, I'm going to put a link to that tutorial in the description of this video. So to get started, we're going to need a directory. I call mine app_music_search. And the latest command that I ran was mamba create-n music app Python 3.10 to create a virtual environment. So I created my virtual environment. I need to activate it. And then now we're going to need 3 packages for this product. So we're going to use install Qdrant client pandas. We're going to be using a really cool tool called NiceGUI to create our app. While that installs, we're going to download the payload.csv. And we are also going to download the embeddings file. So if you scroll down in the tutorial, you're going to get to a section called data. Actually, the session is in the Qdrant Cloud. So you're going to click here, and you're going to find the audio vectors, and then you're going to hit download. It's going to ask you if you want to download it. I promise you that it doesn't contain any viruses, so feel free to download it. Now that our apps have been installed, our packages, we're going to clear here, and then we're going to move the audio vectors into our current directory, and then we are also going to move the payload. Now, if you list the content in these files, then you already have your audio vectors, your payload, and so forth. So now you can go into our editor. I'm going to use VS Code, but feel free to use whichever editor you want. Now that we have our development environment set up, our IDE ready to go, and the 2 files that we're going to be using downloaded, the next thing that we're going to do is that we are going to head to Qdrant Cloud and create an account if you don't have one, or sign in if you already have one. So I'm going to use my GitHub account, and as you can see, we're going to be greeted with a setup to create our first cluster. And that's exactly what we're going to follow. I'm going to call it music cluster, and this lands under the free tier of Qdrant, so you will not have to spend any money to be able to follow this part of the tutorial. So we're going to create a free cluster, and then congratulations, we get a message. You have created your first cluster. It has 1 gig of RAM, half a CPU, and 20 gigs of disk. I'm going to click continue. Then we're going to create an API in order to access the cluster. Yes, we're going to attach it to our music cluster. We're going to say yes, give it the API. Then we're going to copy it, and then we're going to hit continue. And actually, Qdrant gives you the code that we're going to need in order to instantiate and complete our setup. So now that we have what we need, we are going to go back to our development environment and create a new file. We're going to say vectors to Qdrant, and we're going to add it to a notebook. So here we're going to say import from Qdrant, import the Qdrant client, and the models model. We're also going to import pandas as DD. We're going to import NumPy to load our embeddings. I'm going to close up over here, and I'm going to add the code that we just created. As you can see, we successfully connected to our cluster. Let's go back to check what we have. We're going to complete it. And now here we see that we have the status of the cluster, the provider that we're using behind the scenes, EU Central for AWS, the capacity, the configuration, and where it lands in the free tier. So we can see code examples, the version that we're using of Qdrant, the cluster URL, which we already have it. We can open up a dashboard. We can also check out the logs. If we come here, we can go and see the logs. You could go to the danger zone and delete your cluster if you don't want it, but definitely don't do that if you're going to be using it. You can see what has happened since we created that cluster. Metrics are going to be tracked here. And then the overview is going to tell you what capacity have you used and so forth. All right. So now let's go back here. And what we are going to be doing now is that we are going to load up the payload or metadata that we're going to be using in our collection. So remember that is a CSV file. We're going to evaluate the first few rows. So we can see what we have. So we have an index, the IDs of every song, the artist, the genre, the name of the song, the subgenres, the URLs of where the song is at. It is in an S3 bucket right now, every song, the artist and the song together, and then the photos. These photos are not perfect, but they do serve a good purpose for this tutorial. Our next step is to load up the embeddings, and you can check them out by slicing the first two rows, the first two rows. There you go. So the next thing that we are going to do is that we are going to extract the index from our metadata. Let's say index. We're going to make it into a list. And now, for the last piece of the puzzle, we are going to create a payload from this data frame. And we're first going to drop the index and the IDs. This one, because it's the clones. And we're going to make this data frame into a dictionary. And the orientation for it is going to be in records. That means that every row is going to be its own JSON object. Yeah. And the next step is to use the Qdrant client we created to create a collection. Excellent. Now we have successfully created our music vectors collection. And the next step for us is to load up our data into Qdrant. So for that, we're going to do batch size of 250. And then we're going to create a loop where we're going to iterate over our vectors to upload them piece by piece or little by little, chunk by chunk. So we're going to say for I in a range from 0 to the length of our metadata, the amount of rows that we have, the amount of songs represented in our sample, then we're going to use the batch size as steps. And then next, we're going to take the batch of IDs index. Then before that, should create a low threshold. So low threshold we're going to take the mean between our observation, for example, in the loop, plus the batch size, and the metadata check the amount of songs in our data. Okay. So from here, we're going to take from I all the way to the low threshold. We're going to duplicate this and do it again. Okay. So now we have our mini batches that we're going to be using to upload the data into our cluster. So we're going to say Qdrant client at observe. We're going to use our collection name, which is music vectors. And we're going to insert points. And from the models module, we're going to use the batch method. And we need three things. We need the IDs, for which we're going to use batch of IDs. We need the vectors, for which we are going to use the batch of embeddings. We're going to make this a list. And then we need the payload, for which we're going to use our batch of payloads. Next, we can run this cell. Oops, I called it payload, not payloads. Excellent. All right, so that took about 37 seconds, as you can see down here. And what we can do now is we can go to our cluster and check what we have. As you can see, the utilization has gone up, the memory RAM, and the CPU as well. And now let's make sure our collection has been created successfully. We're going to use the method count. I pass in for our collection name, music vectors. Notice that we do have indeed the vectors created. So now it is time to create our app. We're going to create a file called main.py. And one of the things that we want to do is we want to import the exact same import that we have here. But this time, we also want to, from nice GUI, we want to import the UI. We also want to copy our current client. So and from here, we want to start writing the code that is going to build up our application. Now that we have our application up and running, let's talk about what just happened. First, we created a file, main.py, and in that file, we started constructing an application component by component. The tool we use is called NiceGUI. If you have never heard of them, it's a fantastic tool that allows you to create applications and websites with a lot of interactivity in them. Is similar to Streamlit, but a little bit more flexible in the things that you can do. So I highly recommend you that to check out the documentation. You can add to every single component, classes, CSS classes, Tailwind CSS, style. You can go to a second level or to a lower level with their API, and you can talk directly to Fast API, which is the tool that is NiceGUI is built on top of. It also has great support for async functionalities. So the tool that we created, what we did with it was imported all of the packages that we needed, the Qdrant client, the models, the pandas, SPD, NumPy as MP, and then NiceGUI as UI. Then we said, okay, I want to create a label and I want to put it in the middle of my application. That label, I want to color it with this specific hex number. I want to increase the font size, and I also want to add some weight to the fonts. I want to put this in the center. Next, I want to add a subtitle or a subheading. So we're using Markdown for this, and then we put it in the center. So technically, you can go ahead and do this here, and then we change the title that you have or the size of the title that you have. Next, we have our client here, and we have it connected to our API because we're going to be making calls there. We read in the payload.csv. We create a list containing the artist name at the beginning, followed by a slash, a space, a slash, a space, or a dash, not a slash, and the song of that artist. We create a list and then we sorted it, and then we create a little function to create cards. These cards are going to contain the image of the artist and a little bit of description. That description is going to be the artist name, the name of the song, and then the genre of that song. In addition, we're also going to have a score. The reason we have it here into a try except is because when we select the very first song that we want to listen to, an artist, we don't want to showcase the score because we're only retrieving that value. We are not comparing it to any other vectors. And then lastly, we're saying, okay, once you have that song, give me the URL and then put it into an audio file so that we can listen to it. Once the song finishes, I want you to notify me that the song ended. So that is the function that is going to create music cards. So I can show you what that looks like. So say we come here and we select, let's see, a classic one. So we're going to go and select Bach. Okay, here's Bach. And here's the little card that I mentioned. And then underneath it, you're going to have the song. You can download it. You can increase the speed. And just so you know, these images are not going to be perfect. I used the Bing image search API, and I got images for each one of the songs that we have here in the dataset. So not all of them are going to be perfect, but they're a good proxy of if the name of the artist was well written and is a well-known artist, then it is very likely that it's going to have the right picture in this dataset. But since this is for illustrative purposes, then this works fine for our example. Okay, next we have something called, we have a function called get vectors, but this function is a little special. And the reason it's special is because we're going to use it as a callback. What is a callback? A callback is a function that upon an action inside a website, we call again and again and again. So you're going to notice something interesting here. We have two elements that have clear. So the reason why we have these two clear methods on top of some variables that we haven't seen yet is because when we call this function back, when we call it again, we want those containers to be reset. So at the very top, we are splitting our song by the artist and the song. We're taking the last one, which represents the song name. Then we are looking for that song inside our data set. We're getting the index. And then using that index, we're searching in our collection inside Qdrant Cloud for that song. Once we have that song, it's not going to have a score because we just retrieve the vector of that song based on the ID that we got from the selection that the user made. Then we say, okay, given the main artist, we're going to clear this, and then we're going to create a card for the main artist using that song vector above. Then the results, we're going to clear them in case this is the second, third, fourth time we are running this function. And then what we want to do is that with results, if there was a filter applied by the user, I want to create a condition that says, hey, given the genre that the user selected, make sure we match the results to that genre only. And then in the second one, what we're going to do is that we're going to do our semantic search. We're going to say, use the music collections or the music vectors collection, use that song vector that we selected earlier, use the filter above, and then give me the values given by the user. Give me as many values as the user told us to get. And then we're not going to select the first one because that is the one that we selected when we retrieved the artist. So then if there was no filter added, then what we're going to do is that we are going to search normally for the amount of songs that the user wanted to get back. Then at the end, using those results, we're going to create music cards. And that is what you see here underneath back. It is normal that if we have back and then this particular song and the genre is classical, then we're going to get another one of his because he's in the dataset more than once. But we're also going to get other classical songs. And notice here that we're going to get 10. So if we say, hey, actually, I want 20, and we select another one of back, then we're going to get 20 songs back. Very cool. Say, for example, we want to get only hip hop songs or jazz or Latin. So, say we click on jazz, and we know that the Backstreet Boys, they do not sing jazz, they sing hip hop or something else. And say we only want to see those. Now that we have, let's click on let's have a party. And then let's see what we get back. So what we get back, as you can see, is all jazz songs. So our filter works really well, even though this is not the perfect score for our Backstreet Boys selection, we still get exactly what we wanted. So this is our application. Feel free to update it however you like. In the repo, towards the end, you're also going to find instructions on how to package your application into a Docker container. So we could, for example, do it here. If you wanted to build an image with the application that we have packaged today, then we could do it with this command right over here. And then if you wanted to run your application, you could do it with this command over here. You will need to point the Docker container to your API key in your environment. Remember, in this tutorial, we didn't exactly do that, put it in your environment, but make sure you do so for security purposes. And then there's also available for you a Docker image, which a Docker file, which is something that you're going to need in order to create this. Is a very straightforward one. You have a slim version of Python. You point it to a working directory called the app. You copy your requirements, you install them, take everything else, and then run your app. And that's it. I hope you found this tutorial useful. Let me know in the comment section below, and on to the next one.